Hi, Henk Akkermans here, Supply Network Dynamics, Chapter 7, clip number 3. The flow, or more better phrase, the loops in project planning. And what happens in this project is that there are some initial timings for the stage gates, but these timings get, postponed. There is some schedule slippage. And that's true for the timing of stage 2 and true for the timing of stage 3. This happened in the case, and the two loops here explain why that occurred. What you have an initial value for the start time for stage 2. Initially, the initial stage start here is set as 40, week 40. But what do you get? This leads to a certain amount of time remaining in stage 1, and that's a number of weeks, and of course you've got a number of tasks to be done. So these two divided by each other leads to a certain required task completion rate. So a number of tasks that you need to do per week, which tends to be a pretty high number later on. But there is also, on the other hand, the actual development rate. Well, the ratio of those two determines the rate, the degree to which you adhere to the schedule. Well, if you do not adhere to the schedule, then you get a schedule pressure effect. So if you, for instance, in this case, go to the data points, if you have, say, 2 times as much tasks that you need to develop per week as you're actually doing, there is not really a schedule pressure. If it's 4 times as much, you get already an effect on the schedule. And that effect on the schedule leads to an increase of the schedule start time. So this is a modest effect for the start of stage 2. For stage 3, which has precisely the same structure, it gets to be a big effect. Oh, by the way, this required task completion rate is also an input to the capacity allocation and capacity calculation flow that we discussed in clip 2. Stage 3 doesn't have the flexibility to have a later start of stage 4 that would be. But what you do have here is still the total project duration, which remains fixed. So the amount of time remaining in stage 3 remains fixed. That definitely becomes less and less, and so the required stage completion task rate also becomes higher, and it becomes a very high number indeed. What these loops also have is a check whether or not the stage has started, because the required completion rate here is not really that relevant for stage 3 before stage 3 has actually started. Else you would get people allocated to stage 3 to do the work here in these tasks where there are 1,000 tasks from week 1. But it's not really the time of stage 3. So that's what this Boolean value does here. It says if the time is greater than the start time, then 1, else 0. And next you multiply here by this by stage 3 started, yes, no. So if this is not yet started, it's 0, so this whole thing becomes 0 as well. And there are a couple of similar Boolean values for stage 2 started and stage 3 started, again with the same if-then logic. There are also some switches here. This switch for slippage indicates it's a policy lever. Slippage is not really what you want, it's a decision to do this, yes or no. And in the model, in the simulation, you can also play with the option, as you have here, switch slippage. What happens if you don't? If you do get slippage, the schedule gets delayed. If you turn this off, the schedule is not delayed. So that's what these switches do. Basically, here you see again, you multiply by switch slippage. If switch slippage becomes 0, then you do not get any delays from the original timing. Okay, that's the main story about the project planning loops.